So now on this video, we're going to start with an application of trig functions, which is called simple harmonic motion. This is used with the sine or cosine function. So you can be given in this form, f of t equals a sine omega t, or f of t equals a cosine omega t. And in problems, you can use either one. You just use whichever one's most convenient for the physical situation that you're modeling. That is an omega, not a w. It's a Greek O. And that omega has to be greater than 0 for this. Okay. The a could be positive or negative, but it's usually not 0. A equals 0 would be just a flat line. F of t equals 0, right? T is usually in seconds. It could be in other units, though, but most often it's in seconds. And t is time. For simple harmonic motion, t is time. The amplitude is the absolute value of the coefficient, absolute value of a. Amplitude is never negative. Just remember that. It's never negative. It's never 0. Amplitude is the distance the wave gets from its center line. And it's a distance, so it's positive. Okay. So it's the greatest distance of the wave from the center line. Here we go. So frequency, you take omega, that's the coefficient of t, make it positive if necessary, and then divide by 2 pi. Okay, and the wavelength, also known as the period, is the reciprocal of the frequency. So you just take the frequency and flip it upside down. So it's 2 pi over omega. So I remember the frequency, that's the easier one, and then just flip it upside down to get the period or wavelength. So the dividing by pi, why do we divide omega by pi? It scales the unit circle down to give a circumference 1 instead of a circumference 2 pi. So the frequency will then be counting how many times the angle goes through 360 degrees per unit time. So if we're talking about seconds, how many times per second the thing goes through 360 degrees. That's on the in the CS plane, right? Where the unit circle usually would be. So the frequency gives cycles, how many times around the circle, cycles per second, which is what Hertz is the definition of Hertz, which is abbreviated Hz. So I'm sure everyone's heard of Hertz before, and you've probably heard this expression, cycles per second, as well. Anyway, that's what omega over 2 pi is. Then the wavelength, or the period, is the units of that is actually seconds per cycle, which is kind of interesting. Should be in something like meters or something, right? But that's the way it works out. So here's the graph of one of these things. Y equals a sine of omega t. A is this point up here, how high it goes and how low it goes. This happens to be centered on the horizontal axis. And that's because there's no plus something on the end. Okay. And then this is one wavelength is 2 pi over omega. So that's what these things mean physically. Notice that if omega is 2 pi, which happens sometimes, you'll have a sine 2 pi t. Then this point is 1, so the wavelength makes the wavelength 1, which is kind of nice. You might see that at some point.